Anton Kutepov, the next speaker, will talk about the Open Security Collaborative Development Initiative. Hello, everybody. Hi there. My plan today is to tell about how OSCD is going to help us make the world a little bit safer and secure. Also, I'll tell you how it's actually inspiring security professionals themselves and their teams. My name is Anton. I work for the Expert Security Center at Positive Technologies, and I'm very busy documenting and identifying attacks at corporate networks, using primary logs for that. I'm also a contributor to the Sigma and Atomic Red Team projects. My speech today will consist of two parts. First, I'm going to explain what OSCD is like, as seen by the participants. So it's a kind of insider look. So for example, I'm going to tell you how we developed rules for Project Sigma in the second sprint, as well as, a brief Atomic Red Team task creation example, and also I'll tell you about cross coverage. In the second part, I'll show how this initiative impacted me, how I became a more active open source contributor, the kind of activities it brought into my life, and how it impacted the PT team. So, open security collaborative development. So, in order for you to understand what this initiative is, I should probably start by explaining what in this idea resonates with me and what attracted me on the level of values. First, let me stress that we are all in the same boat. This is true both for the blue team and the red team, because we're all trying to solve the same kind of issues behind closed doors. We are trying to identify potential attack vectors and, well, either develop ways of defending against them or simply to test them. I guess that if we join hands and if we start sharing knowledge and experience on a global level, it is going to benefit everybody, because there will be less redundancy. Ideally, we should be able to build more on what each of us does and develop our expertise faster. At the same time, some global challenges simply cannot be tackled by a single person or even a single organization. But when experts form a community or contribute to a particular initiative which brings different teams together in order to address, certain problems, this will be a winning approach, enabling you to tackle even the most challenging things. Support to open source projects helps to develop the field, and since open source projects tend to be, public and easily accessible, in the future you should be able to develop, say, your own analysis or build something bigger on the basis of several open source projects. So it's effectively synergistic. You can take the best from various projects, making everybody better off. Another important motivation for me to participate in the open source movement is that one should stop fearing sharing his own or her own, ideas, opinions, know-how. In the second sprint, this is what many of us discovered, that we felt more comfortable, having, common discussion of what we had, as opposed to doing, say, a pull request. So it was in the course of the sprint that I noticed that other participants like me started changing their behavior. That was true, for example, for my colleagues. They started learning from this behavior model where you're more public, you come up with your ideas and you stand by them. You speak up. I think it's very important in what we do. Now, I've told you about the things that resonate with me, which I believe will be furthered by this project and the initiative. And I think now is the time for me to actually explain what the objectives of this initiative are. Well, the first one is the support of the open source movement, not just in terms of analytics, but like was the case in the second sprint, we had to do a bit of Python programming in order to develop responders. So I actually believe it is very important to support the movement, and this kind of free knowledge is going to help people come up with new things and develop based on the experience they have collectively. The second objective I had, and I believe it was met in the course of the second sprint, was kind of awareness raising, because the participants and the organizers were able to showcase the right kind of behavior. They show that if you don't understand something, it's absolutely fine to ask questions. And the guys who reviewed pull requests, they were just regular folks. They were on par with the other participants. They showed how you could act differently. And their example, their role modeling worked. Actually, some of my colleagues jumped on the bandwagon and started commenting on the pull requests. So the guys are saying now that since this initiative is not affiliated with any commercial organization, since it's a volunteer grassroots campaign, they feel better, and I do agree with them. Let me tell you about the format now. Formats for Sprint 1 and Sprint 2 were bona fide formats. Bona fide sprints. That is, you had to perform tasks from the backlog in a given period of time. At the same time, however, you are not limited to the backlog. Participants should feel free to propose all sorts of changes. And the ideas they have in the course of the sprint or before the sprint, they are absolutely free to voice them and get very adequate feedback. Starting from Sprint 2, discussions and project management happened over on GitHub, which in my opinion was very, very convenient, because there is no channel hopping between Slack and reading backlog somewhere in Google Docs and so on. This is what happened actually in Sprint 1, and I will cover Sprint 1 in more detail now. It started on the 1st of, maybe on the 21st of October, and it lasted 2 weeks. So all the contribution went to Sigma project, and we only communicated via Slack channel, while backlog and guidelines were available in Google Docs, which meant there were several different areas where you could be active, or in fact you should be active. So you had to switch between Slack and Google Docs, and I found it more convenient in the second sprint, where we had just a single channel. I think it was a very good start, really, because 30 people from 9 countries got together, and we were able to increase the overall number of rules by over 40%. This really inspired me. This realization that I took part in this important movement made me feel much better. After we took stock of the results of Sprint 1, the website said that actually Sprint 2 was in the works and they wanted to continue the initiative. And by the start of Sprint 2, a humongous amount of work had been completed by the coordinators. They did try to provide a much more comfortable environment for the participants because they analyzed all the tasks. They also assessed the amount of time it would take to address any single task. And then detailed tasks were created in the repositories of individual projects, and then these tasks were broken down into smaller bits so that participants could attack chewable, so to speak, bits of work. And you must have noticed that we already have nearly 500 rules in Sigma. So all of them had been checked in order to ensure that they've been correctly mapped and classified in line with MITRE ATT&CK. That enabled proper cross-coverage between Atomic Red Team and the Sigma project. Then all the participants know that individual branches were created in each of the repositories where contribution was expected. And the website featured a detailed how-to guide indicating what kind of new knowledge was sought after. And let me give you simply screenshots. So this is the backlog. We see that for each of the 3 areas, such as attack detection, attack emulation, and incident response, so for each, the amount of time it would potentially take was indicated, and the guide also contained detailed links and detailed rules on proper contribution and creator requests and so on. So after all this preparation, the second sprint started, and we were very much impressed by the amount of work put in by the coordinators. What I should say about the second sprint is that it also lasted 2 weeks. It started on the 5th of October, but the number of projects we were contributing to tripled. Last year we only had Sigma, but this year we also had Atomic Red Team and the Hive. What's interesting is that for the Hive project, a lot of, or some programming was involved, and these were actually the resource heaviest tasks, or let me put it differently. Those who wanted to program in Python, they could easily create, say, responders for the Hive, and thus limit their contribution to programming. Another feature of the second sprint was that it was fully coordinated via GitHub, while backlog and guideline were migrated to the website so that we could find all the links and all the required information there. Also, they updated the logo, and it became fancy and neon, which was a nice cherry on the pie. So, what was this second sprint like? Like I said, all the activity had moved to GitHub, which is indeed much more convenient because there is no channel hopping involved. One of the rules, or rather requirements or wishes for the participants, was that we use a single but a separate pull request for each rule or a test. That was done in order to simplify merging. That did create certain difficulties for us. So what happened was that some people would create sub-branches to the master branch. So I didn't have this problem because I branched off from the OECD branch. But those who didn't do that would often initiate with their pull request the changes that were not in line with the pool of changes being considered. So you may actually see comments where people say, for some reason, we're asked to redo our pull request. That was not too difficult. They actually had to roll back, the few new changes they tried to commit to master, but other people, would simply delete their old pull request and create a new branch and therefore a new pull request. Sometimes PRs were creating their own branches, and I was nearly caught in this trap because GitHub usually suggests that you actually do the merge in the master branch, but we actually had to use the OSCD branch. And what also happened was that people would try to use the same pull request to contribute several rules. Sometimes they did on purpose, and sometimes not so much. For example, they contributed one rule with one pull request, they started doing another one, and they thought that their previous contribution had already been cemented, and they started working on another push, or rather another pull in the same branch, but you know how it works on GitHub. An interesting aspect and an obvious advantage of such joint effort is that you can actually ask the research author directly what it is that he meant in a particular presentation or something. Particularly true if it's a large-scale attempt like we had this year. We had this case, for example, in one of the pull requests. Discussions did not really dead-end it, but it was not entirely clear if there was any progress being made. So then they tagged Timur Herhabarov, who is actually using GitHub a lot. So he was notified of this tag, and pretty quickly he responded and explained everything. And this is obviously a great benefit. I also believe this idea of full participant engagement does work. Actually, in committed pull requests, very often, you can see lots of reactions, lots of smileys, and actually, that's a kind of example I wanted to show to you. What you see here is that this participant created a pull request initiating 233 file changes. Imagine how much he must have been enamored with this idea of making the world just a little bit securer. He did check lots and lots of rows. He changed old syntax to new. He used field modifiers, and he proposed it as pull request. And see how many reactions he got, and lots of kudos and respect. Something I don't remember from Sprint 1, but it certainly happened in Sprint 2, was that other participants would actually do a lot in terms of commenting on other pull requests. So they didn't simply gang on their own pull request, but they actually checked out the other pull requests and shared their wisdom, which means it was like a bona fide open source activity. What I enjoyed was that it was done very amicably, in very positive terms, no categorical statements. Whenever changes were proposed, they were proposed indeed. People would be, very nice and well-behaved, saying, what do you think, and would you be open to doing this, and how would you consider doing that? This is nice, and people do open up to approach like this. I think it's incredibly important for us to actually transmit and convey this message. This is what I'm going to tell all my colleagues. This is something that we should all emulate, I think. In order to show what the second sprint was like on the inside, I want to demonstrate some of the elements from the Atomic Red team activity with a Sigma rule development. So with a test, you can emulate an attack, and then with a Sigma rule, you can actually, or you should actually be able to detect the attack. This is the kind of cross-coverage that I referred to previously. So, Atomic Rat Team Project, I should probably describe it. It's a public repo containing tests and emulations of the activities of the attacker. In order for the InfoSec team not to run all these attacks manually, when they're testing their system, they can simply use this framework and emulate a particular attack and see if their defenses are any good. What should be noted here is that the structure of the repo is based on MITRE ATT&CK classification, which means that any test of Atomic Rat Team will by default be compliant with MITRE ATT&CK classification. Which means that you will always have a mapping to MITRE ATT&CK classification. It is convenient to work with this stuff, manually in text editors, but it is much more convenient to use the Invoke Atomic Rat Team framework, which is also available in the Rat Canary environment. It's a cross-platform framework, and it's written on Shell, and Windows has native shell access, but you can easily use PowerShell scripts for Linux as well. Another big advantage of the framework is that it enables very easy launch and checking of tests. You can double check information on tests, see meta information on them, and also with PowerShell you can do them remotely. Another big advantage is that it comes with a web-based GUI for test development. So how do you install a framework like this? All it actually takes is downloading the script from the official repo. It's called install Atomic Rat Team. You can do it inside the PowerShell. And then you launch the function. And the parameter you need is -get atomics. In the screenshot, you also see that I'm running a check on, it's like a verification. And I'm showing that, I'm requesting here information on a particular technique 1218. And this information is what I got. Okay, let's look now at the creation process, which I broke down into 3 parts. First is preparation, followed by creation and testing. Each stage consists of several steps, and I will cover them in more detail later. So first, we need to decide what kind of attack we want to emulate, and in order to do that, I selected a particular finding by hexaquern. So he discovered that if we change the windir environment variable to the path and folder we control, and launchtm.exe can actually deliver our own code. Now let's check if this attack can indeed be mounted. We'll create a folder called system32. We're creating it in C root, although actually any other directory would be okay, as long as the last folder is system32. There, we'll put a utility that has the same name as the system utility. Next, I will copy there the whole or the full PowerShell directory, but the executable itself I will rename. So I'm using a commandlet rename item So it's going to be called now taskmgr.exe, which obviously is the name of the task manager, findable or locatable in System32. Next, we need to select the right technique, because like I said, all the techniques there are mapped in line with MITRE attack classification. So we need to know which folder this attack should go into. Maybe a new one. This is an attack belonging to a class called signed binary proxy execution. However, it does not match any of the sub-techniques, so we can assume we can write into the folder associated with the master technique or the main technique. Next, we need to check if this particular test has already been programmed by somebody or not. And we can look in the local file system for some keywords or search on GitHub, which is exactly what I did here, as you can see in the screenshot. And if we know which technique it is, we can also use invoke red atomic team, right? So T1218 is a sub-technique that contains 5 tests, but none of them covers the particular scenario we're interested. Which is good, because it enables us to create such a technique and test the creation. This consists of 2 stages. First, we'll launch the web application, and we use start atomic GUI commandlet. So we have certain fields to fill out here. We can add arguments optionally. And next, we need to press the button called Generate Test Definition YAML. This is what the fields may look like for this particular attack. Note the additional argument I'm using here. It enables us to change the basic part of the path, leading to the right System32 directory. After I've pressed the Generate button, I get this modal window where the test is shown as a YAML document. And we can easily copy it. There is actually a nifty copy button provided, and then we can input it into an existing document. You will remember that the file already contained 5 tests, which means that we simply append this new test to the file, starting from string 126, or rather line 126. After we have created the test, we need to check the format. We need to check that after the after the addition of this YAML text, the technique is still functional. And finally, we emulate the attack itself. Well, the syntax check can be easily done using the framework itself. So we use the framework invoke atomic red team. We use the parameter show details brief, and then we indicate the name of the technique. So it will parse the whole YAML document for the information we have requested, and it will show that test number 6 has been added. And it has a very telling name. And next we use the framework to launch the emulation itself. Here we remove the parameter called show brief details, and we start the test itself. So you see that the PowerShell is running, and it's called taskmgr.exe. Next, we start the cleanup procedure. We see that the process has been killed, and at the same time the folder has been cleaned, which means that everything is back to normal. Now let's create a Sigma rule in order for us to be able to identify such attacks. Sigma rule creation consists of 4 stages. I guess every researcher will be exposed to it at the very beginning of his or her career, which is creation of the lab environment. So you don't really need to perform step 1 every time you do it, because by default, most security experts always have it. What you need to do every time is conducting the attack and collecting the necessary logs. Next, you need to analyze these logs and identify attack artifacts in order to convert them into detection rules. Finally, you check the created rule for syntax at least. A lot has already been said about creation of Sigma rules. A colleague of mine and myself spoke at Volga CTF earlier this year, and we talked a lot about creation of Sigma rules there. Actually, there is a link there, and it even has the time codes if you're interested. There is also a cycle of 3 articles on Sigma syntax, in Russian, however. But check out the rule creation guide in English on Nextron Systems. Actually, they are the developers of Sigma. The slide also contains the rule that I have developed, and for purposes of brevity, I'm showing here the way we're going to check it. Note the detection section where we are checking that launch.tm has actually launched task mgr.exe, and that the path is different from the legitimate one. This is not C Windows System 32. That is, it is gonna trigger it if the path is different. And there is also a log source attribute. Next, I want to check this rule using MaxPatrol CM, because I have developed a plugin for the Sigma C converter. Actually, these plugins are called backends, but I sometimes call them plugins because Sigma C will download this plugin and hand control over to it. So let me show how it works and how we can convert the rule. So we are starting the Sigma C utility and indicating a particular converter in the target system. We want to convert a particular rule, which is mpcm and the right configuration. Next, we need to indicate the rule that we are going to convert, which means that I am typing down here the path to the particular YAML document. So now we're going to append this string to the interface of our CM system. In this particular case, that's MaxPatrol. And also, I'm going to group the results here by path to executables. So what you see is that our rule has reacted to the launch of task mgr.exe from a directory which is not considered a system directory, in particular art_test and C system32, which means that all conditions have been met and the attack has been identified, has been detected. So we have developed a test and a set of detection rules, and this is the kind of cross-coverage that the guides have been so verbose about. Let me give you also the results of the second sprint. This is how I'm trying to show that such sprints can actually provide significant results. Well, please note that the repo of Sigma rules went up by 229 rules, although it contained quite a lot. Oh, actually, 229 constitutes a 33% increase, and this is a very good continuation of the of the advancement we had in Sprint 1. Also note that in Sprint 2 we already had 3 projects, not 1, and the number of participants doubled. Total was 61. The number of countries involved went from 9 to 15. I wish I could tell you more about the development of this initiative. And I actually think that the political map is the best way to show it. This is a political map for involvement in Sprint 1 and now Sprint 2. So you will see that the number of countries and the number of people interested in this open source movement keeps growing. So there is a growing cadre of people intent on sharing their experience and their knowledge. Let me switch now to part 2. About the impacts this initiative has had on me and my team. After Sprint 1, I started learning much more about Sigma syntax and what makes it special. And I was able to condense it in a series of 3 articles called Everything You Wanted to Know About Sigma Rules. So I tried to cover all the difficulties of Sigma rules using simple flowcharts and diagrams. I think I've been somewhat successful. Since I've been using the official wiki a lot, I decided to translate the wiki into Russian. And I also propose that this wiki is rearranged into units or modules because some of these units tend to be developing in different directions. So, for example, syntax itself is more for programmers. But you can already create lots of other rules, and this will be orthogonal to the development of the converter or addition of some syntax sugar to it. Moreover, if the structure is changed like this, we can actually create additional language versions of this wiki, which means that practitioners, particularly newbies from other countries, will find it easier to join the project. Also, I want to stress how much it influenced my team. We try to implement a sprint-based rule development pattern, and it proved to be quite effective. Pretty much all the guys were involved, and they did learn the behaviors of Sigma. So we also created merge requests, we also commented on them, and then we merged them, thereby expanding our repository. This helped us better structure the interaction between the team members, and we actually had several different departments involved. We believe that this open source collaboration helped us develop a better and more transparent way of collaboration internally. After the 2 sprints and after this active participation in the open source community, we realized that we want and we will share our expertise outside the company. That's why we decided to create this backend converter to Sigma C so that we can actually make calls to Max Patrol CM. So let me stress, let me point out all the people who have been so much involved. I'm really grateful to them, because they've been contributing their rules with so much gusto and enthusiasm. I remember how I first invited them to participate, and I told them how great it is to share your knowledge. And it was just as easy as telling them about it. They would contribute their rules until the very end, and I'm very grateful to them for their participation. Thank you very much for your attention. Our contact details are here. So please join the community, share your knowledge, and be open to the world. Thank you. I think I can take questions now, if you have any. Inaudible. Timur, you are inaudible. Ah, sorry, I forgot to switch my mic on. So this is an open source initiative. So I realize that all the links and all the resources can be found on GitHub. Sure, absolutely. So you can easily check out what's available, you can download, you can use it, you can contribute, you can propose your own changes. So we are indeed about being open and sharing. And as regards our converter, my plan for it is to rework it. It's currently a proof of concept. I mean, it's fully functional, but I think I can polish the code a little bit, and once this is done, it will also be made available. That's a great initiative. Thank you. Well, it's a general initiative, I guess. I think we need to thank everybody involved. You know, it's the multitude of people who are all showing that every little bit counts if you're trying to make the world a bit secure and safer. Well, I'm just sharing my vision. I don't think this is about saying thank you. But I've been very much inspired, and I do believe people should do more of it. Great, thank you.